everyone, my name is Sushwet Kumar Pandey. Today's presentation is on the unsupervised machine learning Capstone project, online retail customer segmentation. So the goal is to separate the customers into different groups on the basis of similar behavior, attribute or interest. This will benefit the business in creating some tailored marketing strategy to target different group of customers differently. And these are the basic description of the columns present in the dataset. So let's have a look at it thoroughly. Invoice number is the 6-digit unique number assigned to different transactions. Stock code is a unique number assigned to distinct product. Description is the name of product. Quantity, invoice date, unit price is the price per unit. Customer ID is the unique code assigned to different customers, and country is the name of the country where the customer resides. After importing the data set and on doing basic inspection, we found following details. So it has around 500,000 records and 8 columns. We found out that there were some missing values in these two columns. So around 25% of the data was missing from the customer ID column, and around 0.27% values were missing from the description column. We dropped all such records where the customer ID was missing because we were going to separate the customers on the basis of customer ID only. If the customer ID is missing and that particular transaction is not assigned to any of the customer, then we can't actually use that particular record for segmentation. So we just dropped all such rows. We also dropped all the duplicate rows present in the dataset. Finally, we were left with 4,01,604 records and 8 columns. After doing basic inspection and data cleaning, we did some feature engineering. We extracted year, date, month, and hour from the invoice date, created new columns out of that. We added a feature named total amount by multiplying values from the quantity column and unit price column. And we also added a feature named time type to categorize the hour of the day into 3 categories, that is morning, afternoon, or evening. Then we dropped all such records where the invoice number was starting with C because that was actually representing a cancelled transaction. We don't wanted to include cancelled transactions for segregating the customers. We only wanted to include the valid transactions. So we dropped all such records. After doing some feature engineering, we did some data visualization and we explored the dataset a bit. So these are the top values according to the frequency. So these are the top 5 stock code by frequency. These are the product which occurred most number of times in the data set in most of the transactions. This is the count of unit price. These unit price occurred most number of times. And these are the customers which occurred most number of time. That means they have made most number of transactions. These are the top countries on the basis of frequency. So most of the transactions are made from UK, United Kingdom. Most of the transactions are made in the year 2011. Some are also from 2010. And most of the orders are placed in the month of November, followed by October. Least number of orders are placed in the month of January and February. And if we look at this plot, it shows that on Thursday, the highest number of orders are placed. And on the Friday, there are least number of orders placed. On Saturday, actually, there are no orders placed. So it looks like it's a non-working day for the retailer. If we look at these two plots, we can see that in the afternoon, there are most number of orders placed. While in morning, there are a moderate number of orders placed. In evening, there are very few orders are placed. These are the less frequent values occurring in the dataset. So these are the stock code by least frequency. These are the products which occurred least number of times. These are bought less number of times. And these are the bottom 5 countries on the basis of frequency of occurrence in the transactions. Okay. And these are the top 10 countries where the most orders are placed. So again, UK is leading. These are the bottom 10 countries where least orders are placed. So Brazil is the country where very less number of orders are placed. Actually, it's only one. Most number of customers are from these countries. So UK is leading in this category. followed by Germany, France, Spain has highest number of customers. And these are the countries where the very less number of customers are placing the orders. These are the countries where the high quantity orders are placed. And these are the countries where less or least quantity orders are placed. These are the product which are ordered with high quantity. These are the products which are purchased in very less quantity. These are the products which made highest revenue. These are the bottom 10 products which made least revenue. And these are the top 10 product which has highest demand among different customers. These are the bottom 10 products which has least demand or less customer base. These are the customers which made the highest number of cancellations, and these customers made less, actually one cancellation only. And these are the countries where most of the cancellations are from. So again, UK has highest number of cancellation. That is because it has the highest number of orders as well. And these are the bottom 10 countries. So these countries have very less cancellations. These are the distribution of all the continuous features. So quantity, unit price, total amount. Distribution is very much skewed. So we did log transformation on the quantity column, and this is the distribution after log transformation. After doing some exploration on the raw dataset, we created a RFM dataset. So RFM stands for recency, frequency, and monetary. So this is how the RFM dataset looks like. For example, if there is a customer named Anthony and his recency value is 326, frequency 15, monetary is this much, it means Anthony last visited 326 days back. He has purchased 15 number of times, and total amount spent by him is 7,183. So we created a data set like this out of that transactional data set that we were given. And then we started visualizing the distributions of recency, frequency, and monetary. So all of these features were very much skewed towards the right. We did log transformation, and then these are the distributions. So these have become very close to normal distribution, and actually frequency and monetary are actually normally distributed. This is the correlation heat map of all the variables. So RFM is the concatenation of R, F, and M values, which are nothing but the quantile segmentation of these recency, frequency, and monetary. So we just concatenated that. We achieved RFM, and then on doing the summation of R, F, and M values, we got this RFM score. And this is the correlation heat map. So we see that RFM is very highly correlated with recency, but moderately correlated with frequency and monetary, whereas RFM scores are almost equally correlated with all the features. So first of all, we did log transformation on the RFM dataset, all the continuous features, and then we applied standard scaler to scale the inputs, and then we applied some algorithms and started modeling to segregate the customers. This is the pipeline and steps which we followed. So after importing the data set, doing some data cleaning, basic inspection, we did some data visualization, and then did RFM analysis. So recency must be less, frequency must be more, and monetary must be more for the best customers. And after that, we will do modeling. We'll apply these many methods to segregate the customers, and then we'll see the conclusion. First of all, we separated the customers into 4 categories on the basis of quantiles. So we did quantile cut on the RFM scores, and we got these results. So these are the 4 group of customers. These are the stats. So mean and median of recency, frequency, and monetary for all the groups. If you look at the first group, recency is high. That means these customers visited very long back, and they have very less frequency, and monetary value is also very low. So these are the worst customers. If you look at the group number 4, these customers visited recently around 10 days back, and they spent a lot of money and they bought so many number of times. So these are the best customers. So these are the comparison of distribution of recency, frequency, and monetary for all the groups. This is the description of all the groups. So group number 1 last visited 93 to 274 days ago, and they bought around 7 to 20 times, and they spent around 142 to 335 sterling. These are the lost poor customers. Money spent by them is very, very less. They visited long back, so these are lost. And these are the best customers. Group number 2 are the average customers. Group 3 are the good customers. So after that, we categorize the RFM values into 4 categories on the basis of Quantile, and we got these results. So these are the 4 group of customers. These are the stats for all the 4 groups. So group number 1 has they visited long back. Frequency monetary is very, very low. So these are the worst customers. Group number 4 is the best customer. They visited recently. They spend a lot of money and they bought so many number of times. This is the comparison of distribution. These are the description. So group number 1 are the lost poor customers. They are spending a very less amount of money. Group number 4 are the best customers. And these are, so group number 2, these are the customer who used to spend a good amount of money, but they have not visited recently. So we are actually losing the loyal customers. And then if we look at group number 3, these are the good customers. They spend a good amount of money. They visited around a month ago. And then after separating the customers by using some basic methods, we applied k-means clustering algorithm. So in order to decide the optimal number of clusters, there are 2 methods. One is elbow curve, another is on the basis of silhouette score. So if you look at the elbow curve only, 5 appears to be at the elbow of this curve. So we can take 5 as the optimal number of clusters. And if we look at the silhouette score for deciding the optimal number of clusters, then for n cluster equal to 2, it has the maximum silhouette score. So we can take 2. And if we want to maintain a trade-off between the elbow curve and silhouette score, that means if we want the n clusters to be at the elbow or near the elbow and with some good silhouette score, so then 4 is a good choice because 4 is at the elbow as well as it has some significantly good silhouette score as well. So let's visualize these 3 possibilities. First of all, if we make 2 clusters with k-means clustering, so these are the results which we got. This is the visualization of the clusters. So group number 0, these are the best customers because they visited recently, they spent a lot of money, they bought so many number of times. Group number 1 are average customers because average or worst customers because they visited long back. Frequency is very, very low. Monetary, they spend a less amount of money. So let's see. This is the comparison of all the groups. This is the description. So group 0 are the best customers. Group 1 are the lost poor customers. They are neither visiting recently nor they are spending a lot of money. And this is k-means. If we make 5 clusters using k-means, then we'll get following results. So these are the stats of all the groups. Let's look at the description. So group number 0, these are spending a very less amount of money, bought very less number of times and spent long back. So these are lost poor customers. And group number 1, these are the best customers because they visited recently, they bought so many number of times, they are spending a lot of money. If we look at group number 2, these are average spending customers. They bought average number of times, they visited recently. So these are recently visited average customers. If we look at group number 3, these are the customers who used to spend a lot of money. They bought so many number of times, but they have not visited recently. So we are actually losing loyal customers. So these are the lost loyal customers. We need to do something about these. And then group number 4, these are the average customers spending the average amount of money. And this is k-means if we make 4 clusters. So these are the stats. This is the description. Group number 0 are the lost loyal customers. They used to spend a lot of money, but have not visited recently. These are the best customers. They visited recently. They spent a lot of money. They bought so many number of times. These are the lost poor customers. Have not visited recently, and they spent a very less amount of money. And group number 3, these are the recently visited average customers. In the k-means clustering, there is a challenge to predetermine the number of clusters either on the basis of elbow curve or from the Silhouette scores. So we also implemented the hierarchical clustering. Here we do not need to predetermine the number of clusters. We just need to define the threshold distance between the data points. This is the dendrogram. So here we can take two thresholds. The threshold is taken in such a way that the line drawn from this threshold distance intersects the longest vertical line. So if we can take either threshold distance to be 50 or 70. So we have taken two cases here. If we take threshold 50, we'll get 3 clusters because the number of clusters here is defined by the number of vertical lines intersected by this horizontal line drawn from the threshold distance. So we are getting 3 clusters here. If we are taking threshold distance equal to 50, if we take threshold distance to be 70, we are getting 2 clusters because this is intersecting 2 vertical lines. So let's visualize these two possibilities. If we are taking threshold distance to be 70, we are getting 2 segments. These are the details, stats of all the groups. So group number 0, these are the worst customers because they visited long back, monetary and frequency value are not good. These are the good customers because they visited recently and they have good uh, frequency and monetary value. They spend a lot of money. So group number 0, as we discussed, these are the average customers. Group number 1, these are the best customers. If we take the threshold to be 50, we are getting 3 clusters from hierarchical agglomerative clustering. So these are the stats of all the groups. Group number 0 are the best customers. Group number 2, these are the worst customers. So as we discussed, group number 0, these are the best customers. They are spending a lot of money. Group number 2 are the lost poor customers. They have not visited recently, as well as they are not spending a lot of money. And group number 1, these were actually the good customers. They were spending a good amount of money. They have bought so many number of times, but they have not visited recently. So these are the lost loyal customers. So after all these methods, we also implemented DBSCAN clustering algorithm because DBSCAN is actually capable of recognizing the nested clusters. So we can see that we have obtained actually 4 clusters. So this is the big cluster. Inside it, there are 3 nested clusters. So these are the stats of all the clusters. Let's see the description of all these. So group number -1, customers who fall in this segment, they visited 11 to 107 days ago and bought these many number of times and spent average amount of money. So these are the average customers. Group number 0, these are the lost poor customers. They have not visited recently and they are not spending a good money. So these are lost poor customers. And group number 1, these are the good customers spending a good amount of money, visited around a month ago. So these are good. And group number 2, these are the lost loyal customers. They have not visited recently, but earlier they used to spend a lot of money and they have actually bought so many number of times. It's just that they are not visiting recently. This is the summary of all the algorithms implemented. So first of all, we tried with simple binning method, then quantile cut on the RFM column. So we got 4 clusters in these 2 methods. Then k-means on the basis of elbow curve, we got 5 clusters. And on the basis of Silhouette score, we got 2 clusters. And to maintain a trade-off between elbow curve and Silhouette score, we got 4 clusters. Then we tried agglomerative hierarchical clustering. Then we obtained 2 possibilities from there. So if we take the threshold distance to be 70, then we got 2 clusters. Threshold 50, we got 3 clusters. Finally, we also implemented DBSCAN clustering with epsilon equal to 0.2 and min sample equal to 25. So we got 4 clusters. This is the final conclusion and the customer segments obtained from these different methods. So lost poor customers, average customers, recently visited average customers, good customers, best customers, and lost loyal customers. So Now, the company may identify the customers who are more profitable and provide them with some better services. And it may also recognize the customers, these lost poor customers who are more likely to churn, and can target them by providing some better offers to retain them. So, yeah, that's all from my end.